Your dog lifts their head toward the television the moment another dog barks on screen. They track movement across the room when something runs quickly, and yet they seem to ignore long stretches of programming entirely, uninterested in scenes that hold your attention completely. This inconsistency is not random, and it is not a sign that your dog simply cannot process video the way you do. It reflects a fundamentally different visual system, one that researchers studying canine vision have mapped in increasing detail, revealing a screen experience for dogs that is genuinely, measurably different from the one you are having on the very same couch. Welcome to Hidden Paw Signals. I want to begin the way I always do. Everything you hear on this channel comes from my own personal process of reading, studying, and trying to understand the published science behind dog behavior. I am not a veterinarian, a researcher, or a certified animal behaviorist. This is one person's learning journey through the world of canine cognition, shared with you because the findings genuinely changed how I see my own dog. It is educational content only and is not veterinary or medical advice. If you want to keep learning about what is really happening inside your dog's mind, subscribe now, because that is exactly what this channel is for. Much of what we understand about how dogs process visual information, including screen-based content specifically, draws on the foundational work of veterinary ophthalmologists and vision scientists who have characterized the structural differences between canine and human eyes. Researcher Paul Miller, a veterinary ophthalmologist whose work has been widely cited in characterizing canine visual capacity, has documented in detail how the structure of the dog retina, the light-sensitive tissue at the back of the eye, differs from the human retina in ways that directly affect how dogs perceive moving images on a screen. The most immediately relevant difference involves what is called flicker fusion frequency, the rate at which a sequence of individual still images blends together into the perception of smooth, continuous motion rather than being seen as a rapid series of distinct flashes. For humans, this threshold sits at roughly 50 to 60 Hz, meaning that images presented faster than that rate appear as fluid motion rather than flickering. Research measuring flicker fusion frequency in dogs has found it to be meaningfully higher, in the range of 70 to 80 Hz, depending on the specific study and methodology used. This has a direct and significant practical implication. Older television technology, and even some modern displays running at standard refresh rates, may not present a fully smooth, continuous image to a dog the way it does to a human viewer. To a dog with a higher flicker fusion threshold, older or lower refresh rate screens could potentially appear to flicker or strobe rather than display fully fluid motion, a phenomenon largely invisible to the human eye, but potentially quite noticeable to the dog watching alongside you. This single difference helps explain a pattern many owners have observed without understanding its cause. Dogs often show much stronger engagement with modern high refresh rate displays and with content specifically featuring fast, sudden movement, such as wildlife footage or other animals running, compared to slower-paced human television programming, which may register to a dog's visual system as a less smooth and therefore less visually compelling experience than the same content appears to a human viewer. Color perception adds another significant layer of difference. Unlike the long-standing myth that dogs see only in black and white, research on canine color vision, building on foundational comparative work characterizing photoreceptor types across species, has established that dogs are dichromatic, possessing two types of color-sensitive cone cells in their retina compared to the three types found in most humans. This means dogs perceive a color range roughly comparable to a form of human red-green colorblindness, distinguishing blues and yellows clearly, while having significant difficulty differentiating reds, oranges, and greens, which likely appear to a dog as similar, muted yellowish-brown tones. A television screen filled with the warm reds and greens common in many human-oriented programs and advertisements may simply not register with the same visual richness and contrast to your dog as it does to you, while content featuring strong blues and yellow tones, certain sports broadcasts, nature documentaries, and specifically designed dog-targeted content tends to stand out far more clearly within a dog's color range. Before we continue, an important pause. As always, what I am sharing reflects my own personal reading of the published research and is offered for education only. It is not veterinary advice. If you have any concerns about your dog's vision, including apparent vision loss, cloudiness in the eyes, bumping into objects, or any sudden change in how they respond to visual stimuli, please consult your local veterinarian promptly, as these can indicate conditions requiring timely professional evaluation rather than behavioral interpretation. There is also a meaningful difference in visual acuity, the sharpness and detail with which an image is resolved. Human visual acuity is often used as the baseline reference point of 20/20 vision. Research measuring comparable acuity in dogs has generally placed their visual sharpness in a considerably lower range, with estimates suggesting dogs see detail at a level roughly equivalent to 20/75 human vision, meaning a dog would need to be at 20 feet to see with the same clarity a person with normal vision achieves at 75 feet. This means that fine detail on a screen, facial expressions, small text, intricate background elements is likely far less resolved and less individually identifiable to your dog than it is to you. What captures their attention is much more dependent on movement, contrast, and overall shape than on fine visual detail. This combination of factors, a different flicker fusion threshold, a narrower color range, and reduced fine visual acuity, explains the specific pattern of canine screen engagement that researchers studying dog cognition and media have begun to document more directly. Studies examining dog attention to screen content, including work using eye-tracking technology adapted for canine subjects, have found that dogs show the strongest and most sustained attention to content featuring other dogs, fast motion, and high contrast, while showing comparatively brief or inconsistent engagement with static scenes, dialogue-heavy content, or footage lacking strong movement or relevant social cues, regardless of how engaging that same content is to the human watching beside them. The auditory dimension of television watching matters here as well, and it interacts directly with the visual experience. Dogs have a hearing range extending well beyond human capacity at the upper frequency end, and televisions, particularly older models, can sometimes produce certain electronic frequencies, including from older cathode ray tube technology or specific speaker components that fall within a range audible to dogs but inaudible to the humans in the room. While modern flat-panel displays have largely reduced this issue compared to older technology, it remains a documented historical factor in why some dogs showed strong, sometimes anxious reactions to television sets that seemed, from a human perspective, to be producing no relevant sound at all. What I find most useful about understanding this research, in my own process of learning it, is how it reframes something so ordinary that it rarely gets a second thought. Your dog watching television with you is not having the same experience you are having, even though you are looking at the identical screen. They're perceiving a version of that content filtered through a visual system built around different priorities, optimized across their evolutionary history for detecting movement and operating effectively in low light, rather than for resolving fine static detail or distinguishing a wide spectrum of color. Understanding this does not make the shared experience less meaningful. If anything, it adds a layer of appreciation for how differently two creatures sharing the same couch and the same screen can be experiencing the exact same moment. As I always want to close with, everything shared here is part of my own learning process and is offered for education and reflection only. It is not professional veterinary or behavioral advice. If you have any concern about your dog's health or behavior, please consult a qualified local veterinarian who knows your individual dog. No video can replace that relationship. There is also a generational and technological dimension to this research worth understanding, since screen technology itself has changed substantially since some of the earliest behavioral observations about dogs and television were first documented. Older cathode ray tube televisions operated at refresh rates considerably below the flicker fusion threshold researchers have identified in dogs, which likely meant that for decades, dogs watching television alongside their owners may have been perceiving a far less smooth, more visibly flickering image than the humans in the room ever realized. Modern displays, particularly newer high refresh rate panels increasingly common in households, have substantially closed this gap, which may help explain anecdotal reports from many owners that their dogs appear considerably more engaged with newer television technology than they were with older sets, an observation that aligns well with what the underlying vision science would predict. There is also a practical and increasingly relevant application of this research worth mentioning. A small but growing body of work has begun examining content specifically designed around documented canine visual preferences, incorporating higher contrast, movement patterns, and color palettes within the blue-yellow range dogs perceive most clearly, intended for use in settings such as veterinary waiting rooms, shelters, and even specialized television programming marketed directly toward dog owners. While this remains a relatively young and developing area compared to the foundational vision science itself, it represents a direct, practical application of exactly the kind of canine visual science described here, translating laboratory findings about flicker fusion, color perception, and acuity into real-world environmental design intended to be genuinely engaging from a dog's actual visual perspective, rather than simply assumed to be so from a human one. If this changed how you think about your dog's reaction the next time something runs across the screen, share it with someone whose dog reacts strongly to certain types of television content. Leave a comment below. What does your dog respond to most on screen? I want to hear about it. Subscribe if you have not already, and I will see you on the next Hidden Paw Signals. The voice and visuals in this video were created using artificial intelligence. Thank you for watching Hidden Paw Signals.